Welcome, Saurav. Welcome to another episode of Upskill Club. Today we have one of the classical questions that is asked around the world in a lot of interviews. Maybe we'll get to learn, and somebody asks it, and we have something to talk about whenever that incident happens. So today's topic is how do you design a web crawler? Um, and this is author views of designing it for a particular scale. Okay, but these are the predominantly the moving parts that he communicates that will be in any standard web crawler. He also mentioned that a web crawler's scale really impacts its design. A web crawler can be as simple as crawling for all the profiles in your university, and it can be as big as crawling the entire web. So the scale is important of whenever you consider the design. So whenever you're discussing this, we should be discussing about what is the scale that you want to target. But in terms of classic web crawlers definition, it is very simple. There is a starting URL, and you simply go page by page of whatever URLs are there in that particular, starting from that URL, and you download this content. That's it. So that is the classical definition, and this is how the diagram represents. And as I said earlier, a web crawler has actually many use cases. It is not predominantly that we understand. It is actually all used in search engine indexing to understand keep crawling the web. So when we talk about Google's page rank algorithm, it is not just ranking in terms of usefulness. They have a crawler which is running in the background and who is trying to understand what is the relevance of the page based upon particular keyword that is searched. So that they take that keyword as a starting uh, word. They identify the most relevant starting URL for it, and in order to do that, and they use that in their ranking weightage. That is all. So it is used in search engine indexing. Second is web archiving. I didn't knew this before I was reading this. Various government actually have, and we have websites, right, where we can go and see the past history of any website. There are websites who do that. I don't remember its name. There is a website. So what it does is you type your any web URL name, and you can crawl and can move around in the timeline. It will show how that website used to look like. I guess you remember its name, huh? Internet Archive. Yes, Internet Archive.
Something similar.
They also crawl the entire web very religiously. Then there is something very ethically correct, I believe. Governments around the world take a dump of entire web, and they keep it locally stored. So that in case things go south, they will have a good copy of what is happening around the web. And there are some of the public notions, some of the public, let's say, documents which are from US has a Library of Congress. So there is entire download of web year by year, and EU has web archive. Indian government might have. I don't think so. With the current government, it will be explaining that they do or they do not. So India might also have the same. Then there is web mining. So there is a lot of useful and unuseful and dark and undark content on the web. So there is a web mining which happens in order to do the right accurate web mining. Example, financial firms, all these fund managers across the world, they don't have time to go and download everything, right? So what they do is they have their web crawlers intact, which mine the web for particular companies that they are trying to follow or that they are trying to target, and download all the relevant information around about these companies from the web, and mine the content for their use case. Okay, these are there. And then there is again a copywriting. Then there is another copyright. So there are some good web crawlers which are run around the world and just notify the authors, hey, this content is copyrighted. This is mainly useful for news media companies and all that. These guys pay third party web crawlers to get that, let's say, news out. So imagine you published a let's say breaking news, but immediately it can be copy pasted, and somebody else can publish it by one different name. But in order to prevent that, these media company pays some of the web crawling and monitoring companies. Okay, as I said in the earlier, let's say at the start of the discussion, scale is important. So what scale you are trying to target is important. For the sake of this discussion and what author has communicated, these are the assumptions that we will make. First is, how many number of pages will be collected? 1 billion pages ought to be collected per month. Okay, will only be consuming HTML pages, so no PDF, no images, only HTML. Okay, then there is newly added and edited web pages from the existing use case should be considered. They should not be ignored. It's not a snapshot per se. It's in a continuous mechanism. Then there is how long do you want to store? Storage had to be of 5 years at least. Okay. And the pages who are duplicate in content, URL might be different, but if the content is duplicate, they should be ignored from the system. So these are the assumptions, starting assumptions for the solution that the author communicates. In order to serve the same, he says, in order to have 1 billion pages to be downloaded per month, this is the QPS that you will need. 1 billion for 30 days, and this is 24 hours and 306 seconds. Your system should be able to make 400 pages download per second. So that is the QPS you have. And peak QPS, let's say you go 2x, so he says 800 pages per second. That is the requirement for the system. And if we make a blanket assumption, which is average page size is 500k, which are HTML pages. And in order to download 1 billion pages per month, you would need 1 billion to 500k, which is 500 TB storage per month. And if you want to do that for 5 years, it will come around 30 petabyte. So that is the storage requirement for this system. Okay. So now comes the top level HLD part. As you can see on the screen, these are all the moving pieces. All the moving pieces of a standard web crawler, which will be able to serve this requirements. We'll go one by one and understand all of them. Okay. I'll name one all of them. Then we'll talk about one of them individually. First is seed URL. Then there is a URL frontier. URL frontier is calling HTML downloader. HTML downloader is resolving something from DNS resolver. Then it is request is being passed to content parser. Content parser is passing it to content scene, and it has a database link to it. Content scene is passing it to link extractor. Then there is a URL filter, and there is URL scene. Okay, let's go one by one and try to understand all of them. Okay, first is seed URL. Seed URL is basically the starting point of your crawl process. It can be google.com, it can be something.com, it can be something else.com. But having a good seed URL makes sense, and it can differ from geography to geography. Example, it can be simply wikipedia.in. If I had to choose, that will be a very good seed URL, because it is already optimized for search ranking and all that. So it has relevant content. It has deep level of nesting also. But it can be different for China. I don't know if Wikipedia is there, so it can be something else there, something Dia or some Wangu. I don't know what is the Wikipedia of China. They may have some Wikipedia. I don't know. Let us do a quick search. Wikipedia of China. Just China.
No, it's showing Wikipedia pages for China.
Wikipedia.
Alternative in China.
Baidu by K. Okay, Baidu by K is something. So this will be a good starting point of. I don't know if we are allowed. I guess we are allowed. We are allowed. This website is a good seed URL for if you are crawling for China. For I don't know what is for India. India. This is something a good encyclopedia. This is Encyclopedia of India, I guess, based in India. This can be a good starting point for India. I don't know if this is correct or not. No, I don't see. So it can. So the point is, it can differ from country to country or the geography that you're targeting. Okay. So that is seed URL. URL frontier. URL frontier is, as I said, most when you're crawling a website. Okay. Either the content will be already downloaded, or to be downloaded. Okay, so you would need to store a chain of URLs, right? Hey, process this, process this, process this. And so URL frontier is basically a FIFO queue, which takes care of the system and for all the incoming URLs. That's it. Fair enough. Seed URL, the starting URL, URL frontier is maintaining the queue. That is all we understood till now. Then there is HTML download. HTML downloader is basically you give it a web page and it downloads the content of that web page. So URL frontier is maintaining a queue. It is passing this request to HTML downloader. HTML downloader is going ahead and downloading all the content. But as you already know, a DNS needs to be resolved. From name, you would need the static IP or the dynamic static IP of that exact server. So that is what DNS resolver is for. So before downloading a content, in order to download a content, is a HTML downloader will resolve its actual IP from the DNS resolver so that it can download the content. So it's a sub part of the system. Then there is content parser. Why do we need a content parser after you have HTML download because HTML download job is simply to download. It doesn't cares about what is inside the content. That is where content parser comes in, because after a web page is downloaded, it must be parsed and it must be, let's say, validated again. Okay, if this the content is right, is it in the right shape and form, or it is in the right in shape and form that we want to store it, and all that will happen. And is it a malform web page, and all those things can happen. Does it has an antivirus attached to it? All those validation needs to happen. Correct. There is a content parser which will validate the content to optimize all the malicious URLs and all that.
Hala, my question, like seed URLs, say you got the starting point. Okay, this is where I want to start my maybe BFS from. Then even to get more URLs, you'll basically have to parse the page, right? Whatever your
Yes.
seed URL was. So I assume there is one level of parsing also happening at URL frontier to get the other URLs.
No, that will happen later. After the
Then
content,
how would you get other URLs from the
you'll
seed?
get to know. You'll get to know in just in
Okay.
a second. You'll get to know.
Looking forward now.
You'll get to know. Then there's content scene. After a content is parsed, validated, we need to understand, hey, have we done this already to optimize for the storage, correct? And from some data, which is 29% of web, entire content is duplicated. Entire content, and 70% is something something we cannot name here. So if with that definition, 100% is 100% is the content I cannot name here, which may cause some content to be multiple store time. So the content scene is just basically a hash map of things that you're trying to download, identify, giving it a hash, and see, hey, have you already downloaded this content? If you remember, we want to be accurate, not in terms of URL, also in terms of what is the content that URL hosts. The content scene basically validates two HTML documents and keeps a big map, and all algorithm is open there and identifies, hey, if this page hash matches with somebody else's that we already have stored. So if it matches, we don't store it. Example, you give wikipedia.com 10 times. So if for the first time it should go and download, other 9 times it should ignore, correct? And now question is, why does that before all this processing is happening? That is the question you can ask here, because from the content which is downloaded, irrespective of if it was stored or not, it extracts the next set of links. This is where the link extractor comes. URL extractor. See, so what it tries to do is, this is an example from Wikipedia only. This is Wikipedia, the free encyclopedia. It has reference to other pages. So what it does is it identifies the routes, and it appends with the seed URL here. So it identifies, hey, I need to go to wiki and Kongi wiki and wiki and Sikkiken and all that, and it appends with the seed URL, which is https en wikipedia.org. This way it gets chain of extracted URLs from the existing page.
This is basically the web scraping part.
Web scraping part, yes. Cool. The content storage is basically same. You will have two level of optimization. The quickly reference content is in disk, and permanent less uses in memory. So that is classical. Nothing new there. Content storage. URL filter is basically, even if you download, you get a seed URL. Okay, you get the next set of routes. You append that with the main URL, but there will always be some blacklisted URLs and all that. All that will be there, and some of the things that the entire website doesn't want to expose. Example, as you can see, this is an open text which doesn't make sense yet, correct? But this is Amazon's way of communicating, hey, don't go inside these directories. Don't go. It is allowing various, and it is allowing few things, and it is not allowing few things. Fair enough. All this optimization and all will happen in URL filter. Hey, is this URL being allowed? Hey, is this URL being is the URL malformed? Is there is a typo, and all those validation? Is this URL backlisted from our system, and all that will happen here. Okay, so this is URL filter. And after URL filter is done, again we validate, hey, have you already done this in terms of crawling of this URL already? So this is URL scene. URL scene checks, it keeps a track of all the URL you have previously visited, because web is a very, very big space. You can have, let's say, looping, people try to do it, purposely fool web crawlers also. They do it intentionally, and they can do it unintentionally also. So there is URL is already optimized or already seen or not. It's been done. Bloom filter and hash tables are the classic ways to identify if you have already gone through this URL. And if it is done, the URL is stored. If it is not done, it is processed to URL frontier. So let us create a mental map of what all is happening. Okay. The first step one is seed URL comes in, and it gives the information to URL frontier. Okay, URL frontier maintains a long queue. First entry will be seed URL, so it will fetch the list from seed URL, will pass this list to HTML downloader. HTML downloader will resolve its IP from DNS resolver and get the actual static IP. It will give that to content parser. Content parser will download the content and check if there is some validation needs to happen in terms of malinformation for that content. Once the content is downloaded, we'll check, hey, if this content is already seen by our system. The content is already seen, we ignore it. If it is not seen, we store that into our raw database for content. Irrespective of it, if it was seen or it was not seen, we take that content and we give it to link extractor. Link extractor goes through the HTML file, the downloaded content, and identifies the next set of routes it wants to process, and it appends that with the seed URL, so that it gets a chain of URLs to be processed next. After that processing, that collection is done, it passes that to URL filter. URL filter identifies, hey, if this URL is okay or not to be passed, and all those validation happens, and it gives to final validation of URL seen. If URL is already seen by the system, which is all your system through one website or other website, whatever way you have learned on this URL, because wikipedia.com something sports can also be referenced from apple.com's promotion of, let's say, sports, correct? So you can learn on same URL. If you learn on the same URL, it will ignore it. If you don't, if you haven't learned on it, it will simply store in the URL which is being processed, and irrespective of if you have, let's say, passed the information or not, it will give the URL to URL frontier to add it into the queue and further process it. This is the loop which will keep continuing. So we understand the basic structure of a web crawler, correct? Any questions till now, Saurav?
So I think between once the journey starts, the first step URL frontier gets is just the list of seed URLs.
Yes.
So it's not getting those URLs passed, and then it's a loop after that.
Okay, correct. It doesn't vary. So it just, as you said, it only cares about the seed URL, and the system should be able to take care of all the moving parts in terms of, is the content right or is the URL right? Okay. Correct. Now we'll try to deep dive. As you mentioned earlier, we'll be doing a BFS instead of DFS, because web is a very, very deep place, and even if we go in the depth of Wikipedia, I don't think so we'll be able to, due to various reasons. There can be multiple loops, and B, it can be very deep in terms of nodes. So we'll do a breadth first search that is there. Okay, but if you do a standard BFS, which is you open a website, example is here, you open a website, Wikipedia 1, 2, 3, you open it, and you open the chain set of other pages. If you do that, standard BFS will have two limitations for a web crawler's sake. First is most of the links which are linked back to same pages. So which means if you crawl wikipedia.com, you will get Wikipedia, correct? That is a majority that you will get. Or similarly, if you crawl, let's say apple.com, that is a good starting point. Let's say for America, most of the link that you will get from apple.com is apple. Similarly for any other website. I don't think that is true for Google. It might not be, but in terms of directory, yes. But if you do that, you will, and you simply blindly add these in your, let's say everything passes and you keep adding those in your URL frontier, you'll keep making more than decent amount of requests on wikipedia.com only. Correct? So in a way, you will bombard Wikipedia system. So this is in web crawlers term is considered as impolite. And there is a politeness factor of a web crawler. Hey, how polite this web crawler is. So this is not this is something that a standard VFS could not let's capture. So that is problem number one. Second problem is it doesn't take care of the priority of the order, priority of a URL into consideration. What does that means? What does that means? Let's say a website article about Apple's new launch of Apple 14 Pro currently, which is happening, versus Apple.com's own announcement and then this landing page and let's say subsection of Apple 14 Pro.
Yeah.
The standard VFS will not be able to make a differentiation. What needs to be crawled first?
Yes.
So that is the second order of let's say limitation the standard VFS has. So that is those are the two things that we need to solve if you want to, let's say, scale our web crawler. So that is what the author will talk about. So in order to solve both of the problems, they go deep in URL frontier only, because this is where you're processing the URL, correct? URL frontier. So this is what in a way will try to expand in terms of design. In order to take care of politeness, what web crawlers so in what are we trying to do in politeness? We are trying to not make unnecessary request, correct? And so that our web crawler doesn't get considered as a someone who is making a DDoS attack, correct? So general idea of what is happening is, so what author has proposed is basically have a queue, okay, and have a mapping and what you need to do is in queues you maintain 3 different list of threads which are making this request and politeness consideration. If you have made something, let's say, always have a delay if you want to go ahead with the same URL again. You should be downloading one page at a time and from the same host, and you should add a delay in download task, and you should have a mapping of what is happening in your worker threads. Okay, so if you look at design, every single worker threads has independent queues, correct? A, B, C, every one of them, and there are a lot of URLs which are added here. B1, B2, in B1, B2, and Bn, you have decent amount of queues of URL that is maintained. If you go back in design, this is URL frontier. You will get bombarded with a lot of URLs, correct? Through seed URLs. You maintain them in different queues, all of them queues, correct? And before you process something, there is a queue selector, and queue selector identifies which URL goes where and how will they be processed, and they assign that work of, let's say, downloading it into these worker threads. This is where the HTML downloader in a way comes in as part of the design. So it is downloading the HTML, but it is which URL to be downloaded is actually being pre-selected by the queue selector here. Why do we do that? To maintain politeness. So we have already crawled wikipedia.com or apple.com. Let's wait for a minute. Let's wait for a minute. That is all it is happening. Have a look. This is URL frontier and HTML downloader, sub part of HTML downloader combined.
So delay and all would be added at worker thread level, right? Queue selector would just make a queue for them. Okay, these are the URLs you need to hit with the delay in between.
In my opinion, it should be at queue selector level, because worker thread job should be just to execute. Queue selector should, let's say, switch to some first queue is, let's say, apple.com URLs. You have all the seed URL, all the in B1 queue you have all the URLs from apple.com. In B2 you have all the URLs from wikipedia.com, and in B3 let's say you have baidu.com, all the URLs. Correct. It's queue selector job to identify, hey, I have already picked something from B1 and assigned to worker thread. I need to wait for some time before I pick something again from B1. Let's pick from B2 instead and assign to somebody else.
Got it. So worker thread don't have their own queue. They are just executing a single URL.
Executing a task.
Okay. And queue selector is
Queue selector is the one who is, and queue router is basically so that same queues are assigned for similar URLs.
Got it.
Okay, and the mapping table is very simple, as you can see. Wikipedia.com is assigned B1 queue. Apple.com is assigned B2 queue. Nike.com is assigned B1 queue. They are trying to create a mapping from the seed URL.
Makes sense.
Cool. This is fairly clear, Saurabh?
Yep.
Cool. So let's move downside. We've already discussed this. Then, if you remember, first thing was politeness. You should be able. You should be. And second problem is to take care of priority. Okay. Importance of a URL is not, let's say, what author says. A random post about a discussion about an Apple product is not, and which has an Apple keyword in it, should not hold the same weightage if you crawl Apple's homepage first. Correct. So what they do is, before queue selector is there, uh, before queue selector, there is another set of, let's say, another set of queues. There is a prioritizer which sits on top of, there's a prioritizer which sits on top of URL frontier per se, before queue selector. What it does is, it takes URLs and computes the priorities, and it has its own logic. Sorry, and the author has not exposed the logic of priority current till now. So let's say there is a priority order intact. The prioritizer knows which URL holds what priority in terms of, and all that weightage, and it has Q1, and each queue is assigned a priority. Earlier we were assigning each queue a seed URL and all the URLs against it to solve for politeness. In order to solve for priority, each queue has a priority.
Got it.
Okay, each queue has a priority, and queue selector, before selecting queue, selecting a queue higher, it gives weightage to the one which has higher priority. So let's create a mental map, okay, to understand. And this is sitting in my opinion on top of this entire design. Before politeness is solved, it needs to sit before it. Imagine you're crawling the web, okay? There are a lot of URLs which are coming in, where apple.com something, and some article about Apple release this .com is also there. Writer needs to understand, hey, Apple released this thing.com should go in, let's say, QF10. But if something is coming from apple.com, it should go to QF1. And when queue selector is trying to create this mapping for the queue router of URL frontier, it will pick apple.com, that is the earlier queue first. So they will be processed first. They will be given the URL in B1 to B1 first, and they will have their independent route first.
But queue router was also ensuring that everything belonging to one domain fall in one queue, right?
Yes.
And if we don't take care of, and before that, prioritizer is not making sure of key which queue has which URL. It's just sorting queues also. It has priority. Wouldn't it make sense to have a priority queue sort of a structure instead of like let's say
So,
each domain having its own
correct. So
priority
now,
it's sorted.
since you had the same, you are having the same difficulty that I had when I was reading this. Okay. So this is how they have solved. There are two set of queues actually in URL frontier. First queues are front queues per se. They try to manage prioritization. There's second set of queues which manage politeness, and this is the entire design. This is the input queues. This is the prioritizer. Correct. Prioritizer assigns queues in order of priority. Okay, this should be picked first. This should be picked later. That is its job. Okay, and this is the front queue selector. Earlier we had one queue selector, right? Now they are naming it front queue and back queue selector. Front queue selector will give input to back queue router. Okay. It will create a mapping, and then here it will create a mapping based upon the source, wikipedia.com, apple.com, something like that. So first we are simply prioritizing in terms of what should be picked first, and that is happening in form of queues. Those are the front queues, and those inputs are processed by front queue selector, and it is giving that as an input to back queue router. Back queue router is creating a mapping table based upon the seed URL. Okay, the initial URLs you are getting, and it is creating their queue. And then the back queue selector is actually assigning the job based upon, hey, how much time you should wait from, if you have picked some job from B1 and B2 are already processed, you should be picking B3 or BN. All those optimization are done by back queue selector.
Got it. So I think with this design, it also solves for, let's say, if there's a priority between two domains. If we would have assigned a domain specific queue and made a priority queue out of it, we wouldn't have been able to solve for, let's say, if this domain has more priority over the other. So that's what maybe it's trying to solve with this. Okay, domain doesn't matter at the priority layer.
Yes.
Domain only matters at the politeness layer.
Yes, domain matters at the politeness layer. It doesn't matter at priority layer. That is clear to us now. If you have to make it relatable for our use case, urbancompany.com matters at the level of politeness. You should not be bombarding urbancompany.com. Okay?
Mhm.
But if there is an article by for urban company and something, there is a blog by urban company, if we release something and let's say there's an external blog which releases something about urban companies, gig economy or anything like that, so us releasing something should be of higher priority versus somebody else person. And this is the logic. And as I said earlier, what logic is there, author has not exposed. And because this is a very deep topic in itself, this requires an entire book per se in itself, the prioritizer for web only, because it is that big in his opinion. So that's why he has not exposed on what you will decide priority. That is a very deep field of research, of tokens and all that relevance, search what people are searching. So that is there. Once that is done, your domain simply matters at politeness level.
Got it.
So this is clear, I guess, up till this point.
Yes, sir.
So we crawl web. Let's go at the top and let's try to recreate the picture in design. So you give seed URLs. You give those seed URLs to URL frontiers. URL frontiers try to solve for two things. First is priority. Second is politeness. After that, those things are taken care of. You give that to various worker threads, which is HTML downloader. Before that happens, it resolves the IP. And once content is downloaded, it parses that content, verifies it, and checks if the content is seen or not. If it is seen, it just ignores it and moves to the next step. And if it is not seen, it stores it in-house. Then and once the content is given to link extractor again goes to the content, extracts out the various routes that needs to be processed, appends that with the top level URL that you currently are let's looking for, and give it to URL filter. URL filter identifies, hey, if this URL is malicious or not, and all the validation is done. And then we check if URL was already seen by the system or not from any different seed URL or not. If it was not seen, the new URL now is processed to URL frontier, and this loop continues forever. Fair enough.
Got it.
Now, okay, that is what we have learned. There are a few things now author hasn't deep dive in terms of design. It only talks about content. So these are the things that you should keep in mind. First is freshness. We should always keep in mind, hey, web pages are always being edited, deleted, and all that is happening. So your web crawler should always be fresh per se. So what they suggest is the recrawling and recrawling will be very time consuming and let's say computational consuming, and let's say it doesn't have that many benefits. So what are the things that people do is they simply crawl web pages update history, and if page is updated, then they simply pass that to content scene and checks if the content was updated or not. If it was done, URL and content is updated. Okay, and then they also prioritize URLs at the top level in prioritizer, and they only recrawl for various top level let's say URLs only, not for all of them. So those are the two optimization that they do in terms of optimizing. In storage, it is classic. There's nothing new, hence I don't want to discuss it further. It is mainly having various quickly let's say things which are being resolved quicker should be in there should be in memory, and which are not, and everything should be in dump, and the caching mechanism and all that we learned earlier should be done. Okay. Robot.txt, this was new, as I explained here. Every website by design, you name a website, let's say this is website being polite and explaining this to company, these crawlers. See, you have robot.txt for every single web which is out there. Google.com, every single website exposes its own directory to crawlers around the world. Hey, don't go inside this. Hey, you are allowed to go inside this. Example, it is not allowing go inside index.html. It is saying, hey, please don't download my landing screen. Okay, but it is allowing search about static, all those top level searches default. So all it is allowing, Google is allowing that. Let's say if you talk about urban company, what do you think? Do we have robot.txt or not, Sarah?
We have, I think.
Yeah. We disallow a lot of things. We only allow customer cities. Optimizing for SEO. Ki, hey, crawl our SEO pages. Don't crawl everything else.
Got it.
Okay, so this is standard practice, and there is also sitemap and all that which happens. In terms of performance optimization, it is basically spending on your infra, having multiple crawlers, doing a distributed job, having multiple distributed servers, and all those classical things that we have already learned. So nothing new there. It is also, if URL is too big, you can download distribute job into multiple part, and you can give subset of URLs to one set of servers, one subset of URLs to other set of servers. All those optimization are done. For distributed crawl, so you're crawling one website, but it is some of the part is being crawled in Singapore, some of in Mumbai, some in California. All that might be happening. Okay, and this is something new. That they also need to cache DNS continuously, because their response, it is a web crawler, right? It needs to continuously run. So if it is dependent on a third party server which gives callback, let's say in 200 ms, the entire operation will slow down. What they do is they have continuous DNS resolvers results caching, so that the resolution is faster, and they have a sync job to keep updating it. So they spend decent amount here. Locality we have already discussed. Shorter timeout. It is more about having. So you need, because if the content is too high, and if you're going to inside loop, you need to have a timeout. Hey, this is the amount I'll spend on a website. Those kind of logics are built in. Robustness is basically in order to, let's say, system robustness, and you want to distribute the effort, right? So we learned in one of our session consistent hashing earlier. How do you distribute load on various servers? That is being implemented again here, because it is a distributed system, so that load is equally dispersed around the world. So now this is something new. So in order, so question is, what happens currently? We're only downloading HTML, correct? What happens if you want to download PDF tomorrow? Do we need to change entire design? No, that should not happen, because we have already segregated our system. We only need to have validators in terms of content scene. Okay, the link extractor will be there, and there will be PNG downloader, and there will be web monitor. So what is the role of these guys? It is basically, you have added new content, PNG downloader will take care of PNGs which is inside an HTML page. Then let's say revalidate them also if you want to store them independently. And if there is a link inside these guys, or there's a metadata that you want to extract from these PNGs, that can also be done. So that is extensible. That is what the author says. Okay. Then there is so this we have already discussed. We need to have hashes for various pages to identify if this page was already downloaded. And this is something new. So there are spidertrap.com. So this is spidertrap. You can keep adding. This is an example that people use. You can keep adding far, and it will land on the same URL. So people create these URLs also. So you need to identify, and if you remember, one of the classical question is there of linked list. How do you identify there is a loop in linked list? How do you identify there is a 6 in linked list? This is where you run two counters and see if you're mapping on the same node or not. All that can be done here, and that's about it, I guess. That's about it, I guess, for the topic. Any questions from your side, Mr. Saurav?
This design overall is also like a very good learning in terms of segregation of responsibility.
Yes. This was a very good learning, and as I said, we have only deep dive into one of the things, which is URL frontier. We were not able to deep dive into various other aspects also. So web crawler as a design is way bigger than this, but it helps us to identify, hey, something as big as web crawler can have so many moving parts, and they should be an independent entities in themselves in the entire system. So that system is very extensible. So that was one of the key learning from web crawlers also.
Correct. If you need to pass different kind of contents, then you only have to change one particular component of it.
Yes.
You don't have to change the complete cycle.
Yes. So that was one of the good learning. So the root capability of is the content seen is there, and if the URL is correct. So it in a way helps us to understand what is the root thing that you want to solve, and everything else should be extensible. So you should design your system around the basic thing that you want to ask. Example for us, it can be place a request and fulfill it. What it takes to place a request, and everything can be moving part inside. If there is a payment, it can be extensible. It is not needed anymore. There's an address, it should not be needed anymore. But this is the way that you want to create a request and fulfill it also. Similarly, that is a journey of a request. That is what should we think about in our system, and we can map out what are the inefficiencies in terms of, hey, is this part extensible or not, if we have to do that exercise for our current firm.
Yep.
Fair enough, Saurabh?
Yes.
Anything else? So thanks for tuning in, Saurabh. I guess this was a learning session for both of us, and then for various people who will be watching this video or the text. I guess that's it. See you in the next episode. Cheers.